Hi, so here we are on Sunday the 9th of March 2025, and a lunar eclipse is coming up this coming Thursday into Friday, depending on your time zone. And in this video we're going to look at a few different locations and the circumstances of the eclipse and get a sense of what we might want to try to achieve photographically for this event. It's a total lunar eclipse. It will be visible across the Western Hemisphere, from Europe, across the Americas, out into the Pacific. And each different location is going to have a very different experience of the eclipse in terms of what's possible or worthwhile attempting in terms of the photography. So let's dip in and look at our first location out in the Pacific in Hawaii. Okay, so I'm at app.photoephemeris.com, the web app. I have Google's hybrid satellite maps selected here, and I have the pin located out here in Hawaii for the purposes of looking at this eclipse. Before we jump into the details, let's just orient ourselves with respect to the state of the moon in March of this year. A few things going on. So this is the events view. I have the 2025 tab selected, and if you just eyeball down this list, you'll see there's a whole bunch of moon-related stuff going on. We have the lunar perigee, which happened on the 1st, which is when the moon is at its closest approach to Earth and therefore has the largest apparent size in the sky. We're past first quarter. Today's the 9th, so this was a couple of days ago. On the 7th, the moon reached its maximum declination of plus 28.7. And you may recall from some webinars we did last year that right now we're in the middle of what's called the Great Lunar Standstill, which is an 18.5-year cycle where the moon reaches its extremes of declination, which means you may see it at its most northerly or most southerly points in the sky over the course of a year or two. We're in the middle of that now. So this is a high value. You're never really going to see the moon at a high declination, more or less than that. And then we have, in this time zone, which is Hawaii, on Thursday evening, the 13th, a total lunar eclipse, which has a number of different phases. You can see the contacts P1 through P2, and then U1 through U4, coming up over the space of a few hours on Thursday evening. And in the middle of that, you'll see full moon happens. Lunar eclipses, total eclipses, are always associated with full moon because the moon lies in the shadow of the Earth. So you need the sun and the Earth and the moon to be all on the common axis, with the moon the other side of the Earth. And those are the circumstances of full moons. We go through the equinox, we go through the minimum lunar declination, and then we also get a partial solar eclipse happening towards the end of the month. And I'll do a separate video on that later on. Let's just jump in and have a look at the details of this eclipse to get started. Let's just start at the beginning. And I'll zoom in the map here. I chose a location up on Kauai, and hopefully you'll see why as we zoom in a little bit. This is a beach, Anahola Beach it's called, and there's a beach park. And I've put the pin up here towards the north end of the beach. This is the direction of moonrise. So when the penumbral eclipse begins, that is actually before moonrise, so we're not going to see anything until then. When we get to moonrise, the moon will be in penumbral eclipse, which means it's slightly fainter, and you might see that slight darkening. It will be on a particular side or limb of the moon, which depends on each eclipse. I have another video which I'll link in the description below, which talks through a whole series of previous lunar eclipses and photographs of those, and it includes some details on what a penumbral eclipsed moon looks like, so you can get a sense of how that might appear. But that should be an attractive moonrise out over the ocean to the east here. It's happening just before sunset, so it may be pretty low contrast, difficult to see, but it'll be there. And certainly once you get, say, 10 minutes past sunset, so we just advance here to, say, 10 minutes beyond or thereabouts, and you see the moon is still low on the horizon, 3.47 degrees, 3.5 degrees. So that's sort of 7 moons worth above the horizon. That will be an attractive sight, clouds permitting. We don't get into the partial phase for another 15 minutes or so. This is when you'll see the chunk taken out of the moon. There'll be a distinctly darker section visible, and that will progress through to total eclipse at around 8:30. And this eclipse is a magnitude of 1.17, which is decent. It's not as deep an eclipse as many, and that's partly a function of the fact that we are not particularly near perigee. In fact, we're closer to apogee. You can see the relative size of the full moon's disk versus the average is about 3.5% smaller in apparent size than it would be at its average size. That doesn't affect whether this is an event worth photographing. Of course it is, and you can compensate for a slightly smaller size of the moon in the frame with your choice of lens and focal length and so forth. Let's go to the point of greatest eclipse here and just have a look at what's going on. It now might become obvious why I put the pin towards this northern end of the beach. By the point of greatest eclipse, we are the moon is moved around to the south and it's moved higher in the sky. It's about 31 degrees above the horizon, so it's a little bit away from the horizon, but a wider angle view of this should make for an attractive photograph. It's low enough to do a successful wide angle shot. Once you're getting up sort of 45 degrees and plus, you're probably thinking about maybe going for the telephoto shot instead. So that's how we're going to see this eclipse in Hawaii. Let's move a little bit further eastward into North America and see what's going on there. Let me search for a new location. I'm going to come to Boulder in Colorado, where I'm located. So we'll switch over there. Let me just choose a different map, a little bit more legible. And we're now on Friday the 14th of March because the time zone changed significantly from Hawaii. And if I look at the time of greatest eclipse, a few things to note. One is the duration of the eclipse is more or less the same. The magnitude, the greatest magnitude, MU, umbral magnitude, is the same, 1.175. Full moon is happening. It's a little bit closer based on where we are on the globe. That's a topographic difference. And we're later at night, so this is at 1 o'clock in the morning. And you'll notice a couple of things. One, whereas in Hawaii, the moon was sort of off here just to the southeast and at 30 degrees above the horizon. Here we are more or less due south and at 52 degrees above the horizon. So this is probably going to be best photographed with a telephoto lens, a longer focal length. Ideally 200mm, 35mm equivalent or higher. The longer the lens, the larger it will appear in your frame and the more detail you'll have. And it's relatively high up in the sky, so you're going to want to make sure you can angle your camera upward comfortably and view the screen, so check that in advance. If you go and photograph the moon, for example, here in Boulder in the next few evenings, it will be more or less at this sort of altitude earlier on in the evening. It gets later as we go. And you can practice, and you should practice, that you can adjust your equipment so it's comfortable in terms of what you're able to see, and control reach and so forth, and also that you're able to focus successfully. And you can do that in a daytime sky or a twilight sky. It's a similar sort of lower contrast focusing situation as you will encounter during a total lunar eclipse. The other tip for lunar eclipses is focus before totality starts, while you still have a bright portion of the limb that will be much higher contrasting for any autofocus sensors to latch onto. If you're in total eclipse and you have got focus already, then don't refocus. If you need to refocus, then best to do a live view, zoom right in, and take your focus that way. So that's the middle of the US. I'll just zoom out so you can see really where we are here. So we started out over here in Hawaii. We've come up here to to Boulder. And next, for our final location, we're going to head even further east. So I scouted out a location that I'm going to show you next a little bit earlier. I'm just going to type in my little prefix here, TLE 2025A, TLE Total Lunar Eclipse 2025A. There's another one later in the year. And we're going to Tenerife in the Canary Islands in the Atlantic. Let's head off there. Why have I chosen this location? Well, it's because there is a very particular phenomenon which you will be able to observe. There are a lot of advantages to this location for this eclipse. When we started out in Hawaii, you may recall that the eclipse was happening beginning just before sunset, just before moonrise, and the moon was rising in the penumbral eclipse, becoming partial and total. In Boulder, Colorado, it was more or less straight south at its meridian transit, more or less, and relatively high in the sky. And here, the eclipses are happening just before sunrise, and what's most interesting, it's happening, continuing, after sunrise. You may think, how is that possible? How can you have an eclipsed moon when the sun is also risen? We'll talk a little bit about what that is and why it can happen later. But first of all, let's just look at the circumstances of the eclipse. So here we are, so you know where we are, off the coast of North Africa, Canary Islands, there's Europe, there's the US, here we are, here. Very accessible from Europe, popular destination for holidays, vacations, and lots of flights. So it's not too late. You could even do this if you see this video soon enough. The penumbral eclipse starts way earlier before sunrise at 4 in the morning. The moon is at 42 degrees in the sky, and bear in mind that it's getting lower in the sky as we go towards moonset at 7:21. And as we advance, partial eclipse will be happening with the moon still reasonably high, 27 degrees above the horizon over this island here. And the super interesting part starts here at 6:26 in the morning. Now, one thing I'm going to do, the pin is up here on the island of Tenerife on a point just off a road. You can see it's up on you can sort of scramble up from the roadside up to this view. So I wanted to show you the Google Street Maps view of this area. And there was a photograph that somebody's kindly taken from here. Let me just drag the peg man onto it. You get a sense of what we're looking at here. There's a view off to the east, I believe, looking out over the ocean. And if we spin this around, there's the summit of the volcano. Here's the road down below. And here's a view off, there's the other island that I showed you previously. And this is more or less where the moon is at the start of the total eclipse. So you've got a good view from up here. There's lots of other locations you could choose depending on your interest and what you're looking to capture, but this one is an interesting one. So a little cloud in this particular day, but a good view off to the horizon. One thing that's obvious is that we're up here at 8,200 feet above sea level, and we have a view to the horizon at sea level. What that means is that we, the observer, are elevated above the horizon, and that changes the timings and the geometry of things like sunrise and moonset, just a little bit, but it's an interesting effect. You can adjust for that pretty easily. You click here on this is the elevation above the horizon adjustment here, and we say, do you want to adjust the rise and set times for the observer height above the horizon? And if you want to know more about this, click this learn more, and it will open a tutorial on this whole feature, which is available here. There you go. And there's a video, talk you through it in great detail. But briefly, what we're going to do is click yes, we want to adjust. And what is the approximate elevation above sea level at the horizon? Well, we know what that is because in the photo you know that you can see the sea, and the sea is at sea level, so the answer is 0. So you just click submit. And what's happened is that the times of sunrise and moonset sunrise is happening earlier, moonset is happening later. Let me show you that. It's indicating that we should be able to see about 120 miles to the horizon. And when I zoom out, that's 120 miles, that circle there, which doesn't seem implausible based on what we saw in that photograph. If I turn this off, so let's just make a note. 7:09 for sunrise, 7:29 for moonset. And I'm going to turn it off and click submit. 7:17 for sunrise, that's quite a bit later. 7:21 for moonset, quite a bit earlier. So it's quite a useful adjustment to have enabled in these circumstances. Total eclipse, as we said, the moon is relatively low in the sky, so that's going to be a very nice wide-angle shot or telephoto shot from an elevated location such as this. Out over the ocean, kind of, just a little bit skimming this island here. I guess that's called La Gomera, or is that the mountain? I'm not sure. And this is at the start of nautical twilight, so the skies are going to be plenty dark. It should be easy to get a good image of the totally eclipsed moon. Here's where it gets super interesting. Greatest eclipse, we're just about clearing the island at that point. 1.175 magnitude, just before 10 minutes before the sun is going to rise. So not 20 minutes before the sun is going to rise, 10 minutes before the sun is going to rise. And that's because up here, you're so elevated above the sea level that you're going to see sunrise sooner and you're going to see moonset later. So if we click here through to sunrise, at the adjusted sunrise at 7:09, the moon has cleared the island. We're still in total eclipse. It started here, it doesn't end until 7:32, but the sun is up. So what is all that about? This is a particular phenomenon called a Selenelion. And here's a quick article on what it's all about. I wrote this a couple of years ago. There's always somewhere where this is possible. It's basically at the extremes of the eclipse when either the moon is setting or rising. So it's observed just before sunset, just after sunrise. In our case here, just after sunrise. And both bodies appear above opposite horizons at nearly opposite points in the sky. And there's a photograph of what it looks like, and essentially the sun is up. You can sort of see the sun is up because of all this pink in the atmosphere. That's caused by the sunlight passing through it, and yet the moon has still got the appearance of being totally eclipsed. So you think, how might that happen? Well, it's basically, this is us up on the mountain, we're looking at the moon, we're looking at the sun. How does it really work? It happens essentially because of atmospheric refraction. So if you were on the moon, you couldn't see the sun, because if you could see the sun, the moon would not be totally eclipsed, and yet it is. So we know that geometrically the Earth is blocking the sun from the perspective of the moon. But for an observer on Earth who is sitting in Earth's atmosphere, the refractive effect of the atmosphere means that it lifts the sun a little bit in the sky and it lifts the moon a little bit in the sky, and you're able to see both at the same time. So that's what makes this possible, where you can have a greatest eclipse or a total eclipse after sunrise. This is the 2022 example. And if you want to really improve your chances of seeing this, one good thing to do is to go higher above the horizon. And that's because of the dip of the horizon. So when I did that adjustment for the horizon effect, it actually calculates the dip. And if I move myself out the way, you can see just to the right of my picture there, you can see that the horizon there, the adjusted horizon, to the right of my picture is at minus 1.8 degrees. And with that adjustment, that's what changes the times of sunrise and moonset and makes this phenomenon possible. So now you know why I thought I'll share this particular suggested location with you. It's because if you are there at the right time, on a clear morning, you could photograph a Selenelion, which would be a pretty cool thing. One final comment is that in order to really demonstrate that the sun has risen, it's advantageous to have some foreground that's going to be illuminated by the sun at that time. And that's why I chose this particular location on this summit up here. You could step a little bit back here in front of the summit and the sunlight is going to be illuminating that. Here on the 3D page, you can get a clear sense of how this works. So there's the sun has risen, it's illuminating the landscape here from the east, and yet we're still seeing the totally eclipsed moon off over the ocean. And a location like that allows you to get some illuminated foreground, as would places like this here, but not so much if you're down here on the downsloping side to the west. So it's going to be a fantastic event. I'm going to be in England and the clouds don't look great, but we'll see if we can actually capture this similar phenomenon in England. I don't think the odds are with me. Your odds are much better in a location like this. But it would be an interesting thing to see and to photograph. So hope you enjoy this upcoming eclipse and thanks for watching.